to welcome everybody this morning to our grand opening of our Odem Street Wastewater Treatment Facility. This morning really is a culmination of a 12-year planning process that began in December of 2004. At about that time, December 2004 and early 2005, flows from the heavy rainfall we're receiving caused us to trigger some regulatory requirements to begin planning for a new wastewater treatment facility. And of course, we haven't been building the facility for 12 years, but we have been planning it. It takes a lot of time to work through the process of figuring out what you're going to build, where, and how much it's going to cost, and then of course moving into getting that put into our capital improvement program, and then getting funding for it, going through the permitting phase with the state regulatory agency, and then finally getting into design and construction. So it's been a very long time coming, but the result is this new state-of-the-art 4.4 million gallon per day treatment facility, which will serve the citizens of Victoria for many decades to come. In addition to adding new capacity to our system, this plant also replaces the old Willow Street wastewater treatment facility, which was a 1950s vintage trickling filter plant, used very old antiquated technology. And of course that has now been demolished. We're just finishing up the demo of that facility right now. I want to take this opportunity to recognize and thank some of the contributors to making this day possible. Of course, our Mayor Paul Polasic is here, Councilman Jeff Balknight is here, Councilwoman Jan Scott, Councilman Rafael de la Garza, and Councilwoman Josephine Solis. Thank you very much for y'all's input into this. I'm going to ask the mayor to come up and say a few words, and then I have some other people after that I want to recognize. Mayor?
Thank you. I'm excited. And I'm not sure what that says though when you're excited about opening a wastewater treatment plant. I was joking with some of the engineers that I'm kind of an infrastructure geek, which I guess is rare, but to be on a municipal government, that helps, you know. Congratulations, Lynn, and all the department heads on getting this project done. That 12 or 14 years?
12 years.
12 years. And you know, Mayor Armstrong, former Mayor Armstrong, was in the middle of all that, and there were a lot of votes and a lot of debate and a lot of discussion to get to this point. Most of it good, some of it a little controversial, but here we are today. And as I drove over here, I was thinking about what makes a city, and of course that's defined in many ways by different people, but to me, it's not just a bunch of people that all live in the same place. It's the services is a big part of what constitutes a city. And here we are today, you know, opening a large piece of infrastructure that is one of those most important surfaces. I've always joked with people a bit about wastewater and water systems are probably the most we're taken for granted. I think, you know, Lynn would agree. We don't see that. All that investment in infrastructure is pretty much underground. We drive over it every day, but it brings us our most important resource into our homes, water, and it also takes away that wastewater. And we have to do something with it, and well, here you go. So to me, those aggregation of services defines a community in a lot of ways, which I think is fascinating. So I'm so pleased to see this come to a conclusion, and I'm so proud of city staff, Charmel and our former city manager and other staff members that were part of this. It's just amazing, and I look forward to the expansion of this area and serving the city and the citizens for many, many years. Thanks, Tim.
Thank you, Mayor. Okay, there's also some other people here that were very instrumental in getting this project going. One of those is our former Mayor Will Armstrong and former Councilman Lewis Neitch were both very instrumental in getting this going. I'd like to ask Mayor Armstrong if he'd like to come up and say a few words.
You know, Rome wasn't built in a day, and I guess they were working on a sewer plant when they figured that all out. But this was a 12-year project, and the council, I believe, approved this unanimously after quite a bit of controversy. But there's one thing that I want to say, and the point that I want to make, is that no one on the council brought this project to the council. The project was brought to the council by far-reaching and very, very smart, dedicated staff. And that's where most of the really long-term projects come from. And the dedicated staff is thinking ahead, and they brought it to different councils and it was approved, and here it is today. So congratulations to everybody that was involved with this project. Thank you.
You know, I talked a little bit ago about this being a state-of-the-art plant, and I guess anytime you bring on a new plant, $20 million investment, it better be state-of-the-art, right? You better be using new technology. But I will tell you, there was a lot of innovative technology brought in and utilized in this plant that isn't often used at some plants. We used odor control here because we want to be good neighbors to our citizens. Odor control in the form of chemical odor control at the lift station down on Southwest Bend, Jordan. Here, we took some measures to control odor. We covered the headworks where most of the odor comes from. We installed odorless air blowers then that exhaust the air from there and put it injected underwater, used in the treatment process to prevent odors. We used fine bubble diffusers so that we prevent off-gassing, or at least inhibit off-gassing. And then we used high-speed turbo blower technology here, because a big part of the cost of operating a sewer plant is generating air. And so we wanted to be as energy efficient as possible. So we used the latest technology in turbo blowers. We built, and I'm not going to go into this, but we built an anoxic chamber in our aeration basin that you'll see when we're up there. Basically allows for the proliferation of a good kind of bacteria that we want to make this process good. We used ultraviolet disinfection because we use bacteria to consume waste and wastewater. At the end of the process, before we put it back in the river, we need to remove those bacteria. Most plants use chlorine for that. Chlorine is a toxic gas, susceptible to releases. Again, we wanted to be good neighbors, so we're not using chlorine. We are using ultraviolet light. It doesn't necessarily kill the bacteria, but it scrambles their DNA to where they can't reproduce, and then they die because they live a very short life cycle anyway. And then finally, we use, when you get up on top here in a minute, you'll see we use shared walls between these structures, which is basically saves on concrete you got to pour, saves dollars. We were able really to bring this plant in online at about $3.60 per gallon of capacity, and that's pretty unusual. Most activated sludge plants today are costing around $5 a gallon of capacity. So employed a lot of innovative technology and still made a very economical plant, we believe. I'll talk about the process real quick so that when you go upstairs you'll understand what you're looking at. This is a flow diagram of this plant. This uses the activated sludge process. Wastewater treatment is a biological process. It's not like water treatment. It's not a chemical process. It's biological. We rely on microorganisms to consume the waste from the water. So when we're talking about wastewater treatment plants, all we're doing is trying to design an environment that bacteria love. It really encourages them to grow and reproduce and eat and reproduce again. So we start out down at Southwest Bend, Jordan and Bottom Street with a lift station that takes raw wastewater from a large diameter main that runs down to the regional plant, and we pump some of that wastewater up to the plant. It first goes into a headwork structure which has a mechanical bar screen in it that cleans out solids from the water, things like everything from chewing gum wrappers to rags to anything else that gets in the sewer system, and a lot of solid material gets into the sewer system. We remove that and it goes into a dumpster, and periodically it's taken to the landfill. From there the water goes into an aeration basin, and that's where the biological activity occurs. We use aerobic bacteria that need food, warmth, and air to do their thing, and their thing is eating and reproducing, and that's what we want them to do. And so we bubble air in there. It's warm in South Texas. We don't have to worry too much about heat. We got to keep a food source coming to them. And then they consume the waste. From there, the wastewater goes into a clarifier, which is just a settling basin, allows any sludge to settle out. The clear water then goes into our UV disinfection, where we shine ultraviolet lights on the water, and as it passes by there, it scrambles the DNA of the bacteria that are left remaining. And from there, the water goes back to the Guadalupe River at the same discharge point as our old Willow Street did. The sludge off the bottom of this clarifier comes around here, and we pump some of it back into the headworks because we always want to be recycling bacteria so that we have a good, healthy set of bacteria in here to consume the waste. The additional sludge then is pumped through a pipeline down to the regional plant, where it is dewatered using a belt filter press, and then it's taken to our compost site, mixed with ground brush and vegetation, and made into a marketable product and sold. So that's wastewater treatment. Okay, we've done plan overview. I think we're ready to cut a ribbon. If I could ask the mayor and council to come up here and help me.
Okay, I'm gonna count to 3 and cut. 1, 2, 3.
All right.